Hi everyone, welcome to lecture number 29, which is Preorder Traversal, but in an iterative fashion. Previously we have seen the recursive one, so now we'll see the iterative one. Let me explain the first what's a preorder. If you want, you can skip it, or else you can refer my recursive approach also. It will be better. 2, 3, 4, 5, 6 and 7. Okay, so let's see what's preorder is. Preorder is nothing but first you will print the root and then you'll go to the left and then you'll go to the right. So let's see what happens here. So this will be a root. So now you'll print your root 1, you'll go to your left, you'll print your root, then you'll go to your left, which is 4, then you'll print your 4, you'll come back, you won't print this, you'll go to here, which will give you 5, and then you'll come back, 1 is already printed, you'll go to 3, you'll print your 3, then you'll go to your left, which is 6, and then you'll come back and then you'll print your 7. So this is what a preorder means. So let's see how we can solve this in iterative fashion. So to solve in iterative fashion, if we see that in recursion, we will call recursively, right? We'll call repeatedly a function with some base node in it. Okay, but when it comes to iterative, you lose that base node. So how we can keep track of it? We will use something called stacks. I know I haven't discussed about stacks earlier, but stack is basically, it's a single array. You can consider a single array. So this is a stack. Let's say this value is 1, this value is 2, this value is 3. So let's say this is a stack, and stack also has some basic functionalities, like the top of the stack, top value is 3. In stack there is only one way. You will keep one value in and you will take the value out. So that means the last value which you inserted will come out. Okay, when you say pop, you are popping out 3. When you are inserting a new value. Okay, so this is what we are going to use now. So let's see how we can do that. First let's take a stack which will be of value of we'll insert the root node 1. Okay, so now we'll make a for loop. We'll loop until the stack is empty. This stack is empty. Okay, so now let's say we'll print 1. Okay, that's what we discussed, 1. Next we will go to the left and we'll go to the right. Okay, so now see, it's a basic intuition. Let's say if I keep my left node first into the stack, then that means the first which I pop will be the 3, right? See, let's consider an imaginary stack here. Let's say if I put the value 2 to the left node and the right node here, if you pop the next time, you will get the output 3, but the output which you want to get is 2, if you see here, right? So this is the basic intuition, like it comes when you explain the problem to yourself clearly. So which is 2, right? So we should not keep our left first we need to keep our right node. Okay, so let's say we'll pop this value out because we have printed it. We'll cancel this out. Now we'll place a new value which is 3 and then we'll place it 2. Okay, now for the next iteration we'll pop only the top nodes, only concentrate on the top nodes, because stack only has, you can pop only once. Okay, I'll pop this 2 node. I have popped this 2 node. I'll print this values out. Now I'll insert right node and the left node. Okay, so that means I will insert which one, 5 and 4. Okay, so now I'll pop 4 and I'll print 4. Okay, do we have anything to the left or the right? No, nothing. So we won't add anything into the stack, right? We'll skip this. Now the next is 5. We pop this. We'll pop 5 and we'll print here 5. Does this have any left or right nodes? No, right will come back. So what is the leftover value? 3, right? So now 3 has 1 to the left, 1 to the right. Then we'll print the 3 value, and now after popping it out, we'll add 7, which is to the right, and next we'll add 6. So we'll pop 6 and then we'll pop 7, so which will be added like this, right? So this is an iterative approach using space, right? I know recursion also uses some space, which is a stack space, stack tree space. You can consider it as a tree space, not stack space, tree space, because you'll construct that entire tree in the background, right? So it takes some space. Okay, the space of this approach is order of n. Although you don't contain all the elements, what do you say, of all the elements of the tree in a single stack, but at max we can consider we are at an instance we can store of order of n. So the time complexity will also be order of n, because you are looping all the entire tree, right? So you are looping, it will take of order of 1, because you have to loop n elements here. Okay, hope you got it. So let's jump into our coding session. So let's see how we can write the code for this problem. So first we'll initialize a nodes array, which will be with the bt.root. So first we'll initialize with the root, and then we'll loop until the nodes is greater than 0. So first we'll pop the top node out. So nodes of length of nodes of -1. So there is no something like pop or something. We need to use the dynamic arrays to implement our stacks in our Go. So if I have any doubts in that, you can refer to my Go blog. So it is clearly explained in that how to implement stacks, queues, maps, strings, arrays, dynamic arrays, 2D arrays. So you can refer there. Okay, so now we need to pop that out. So to make possible, so we'll 0 to length of -1. So we are simply ignoring the last index, right? So this is not included in an array indexing. So we are simply popping out the last value. Then we'll print the top node dot value, and which we discussed. First we'll try to append the right value, then your left value, right? So first we'll check whether the right is not equals to nil. Then we'll append it into our nodes, or else we'll append next the left, right, and it's just a breaker so that next function doesn't get disturbed because of this. Hope you got it. Got any doubts or questions? Drop them in the comments, and I'll do my best to reply them. Don't forget to like the video, subscribe to my channel if you liked it, or else please make sure to comment it. I'll be improving that. Thanks for watching, and I'll see you in the next lecture. Until then, bye bye.